The lesson we're going to do today is over parallel and perpendicular lines. There's two parts of this lesson, and the first part of the lesson, I think, it's the hardest part mathematically. If you're not super good at math, this first part is going to be the hardest part of today. But the good news is that really the stuff we're doing today is the same thing as yesterday. So the hardest part of today, when you're that part where you're actually solving and distributing and doing different things with that and fractions and all that noise, it's going to be the same thing we did yesterday. Once we have this problem set up, we'll probably put it in point slope form, and then we'll put it in slope intercept form. That'll be the hardest part. It's not going to be hard mathematically at all, and all the questions will actually take not very much time, but it is very confusing. It's the difference between horizontal and vertical, and x is equal to and y is equal to, and making sure you know parallel and perpendicular. And so there's a lot of stuff that's really, it's easy, but it's really easy to confuse. So just to give you a heads up for that. I forgot to put this on your paper. Parallel, the symbol for that is the two parallel lines like that. A lot of times I'll do them like this. Not that we do this very often. And then a perpendicular line, the symbol is an upside down T, which is perpendicular. Those lines are perpendicular to each other. So parallel, I don't think I probably have to go over this, but parallel lines are lines that will never intersect each other. They'll go on forever and ever. They'll never intersect. Perpendicular lines do intersect. They intersect at a 90-degree angle. They intersect at a right angle. The way parallel or perpendicular without looking at the graph is parallel these same all the time. Exact same slope. If one is a slope of 2 and the other one is -2, that is not the same. That doesn't count. They're not parallel. Parallel lines have the same slope. I'm going to be honest, most students do okay with that. Not the easiest thing ever, I get that, and some students still struggle, but most students do okay that parallel is the same. The place that a lot of students struggle is that perpendicular lines, if you look at the opposite reciprocal. What the opposite reciprocal means, so there's two parts. The opposite means it's a positive to negative or negative to positive. So if you have a positive slope, the opposite is a negative. If you have a negative slope, the opposite is a positive. The reciprocal is where you take your slope, that is a fraction, that slope, that fraction, and flip it. So the example I have A over B, the reciprocal is B over A. If I have 2 over 3, the reciprocal is 3 over 2. It's not rocket surgery, you just flip it. So if I tell you to do both, the opposite and the reciprocal, the opposite is going from positive to negative, or vice versa, and the reciprocal is flipping them. To be perpendicular, it's got to be both of those. If it's just the reciprocal and not the opposite, it's not perpendicular. If it's just the opposite and not the reciprocal, not perpendicular. So make sure you're looking at those. I'm going to have you guys do these on your own real quick. I'm not going to take a ton of time to do this, but go ahead and list out the parallel and perpendicular to those slopes. So I listed 5 slopes there. I want you to go through and put the parallel slope, so whatever slope would be parallel to that one, and whatever slope would be perpendicular to that one. I'll give you guys about a minute because then the bell's going to ring. If you want to do this, they're just the same. So you literally just can copy those down. Perpendicular, this one's positive, so we need negative, and then the reciprocal is 2. Number 2 is tricky because they put the negative with the numerator. Now I tell you, I always do that. This is the one time that it might be easier to put the negative out front, because what a lot of people do by accident is for the perpendicular, they say, oh, well, the 2 is negative, so I'm going to change that to positive, and the 3 is positive, so I'm going to change it to negative. Well, remember, if you have a negative in your fraction at all, whether it's in the numerator, the denominator, or out front, those all mean the same thing. That's still a negative fraction. It doesn't matter whether it's on the numerator, the denominator, or whatever. So you need to make sure you remember it's positive. But again, if it helps, you can make the whole thing negative, and that way you can tell the whole thing is positive. Didn't quite get there. Picking up where we left off, if it is parallel, it's the same slope. -2 over 3. Number 3, if it is not a fraction, you can make it a fraction by putting it over 1. So if you ever don't know what to do, if you say, well, I can't do the reciprocal because it's not a fraction, just make it a fraction by putting it over 1. Now, all of a sudden, the perpendicular is not too bad. That was positive, so we need negative. And then it's 1 over 5. And parallel, again, is the same thing. So you can just put 5 for that. Or 5 over 1 is fine, too. Number 4, again, parallel is the exact same. And then this one is negative, so my perpendicular is positive, and then it's 4 over 3. Then lastly, number 5 is just 1. Again, this one's a little bit of an interesting one, but it's not any different than what we've done before. If it's 1, we put it as 1 over 1. So the parallel line is just 1. It's the same. And perpendicular is the opposite, so it's negative, and then the reciprocal. Well, 1 over 1, the reciprocal is still 1 over 1, which is just 1. So again, that's a little bit of a strange one, but we don't do it anymore. The reciprocal of 1 over 1 is just 1 over 1, which is negative 1. Any questions on those before we move on? Because that's the new stuff for today. Other than this, it's, again, very similar to what we did the other day. Okay, so the questions you will have that are on tests and quizzes like this will look something like this. Number 6 will say, write equation of a line in slope-intercept form that is parallel to this line, and it has the y-intercept of 5. Now, this one's kind of nice because I'm just kind of easing you into it. So I want it in slope-intercept form, and I do give you the y-intercept. Later on, we'll kind of have to find what that is. But the important thing to wrap your mind around is this line that they give us, that y is equal to 3x minus 18. We only want the slope of that line. We do not care at all about the y-intercept. The only reason they give us that line is because I want the slope. So I want a line that is parallel to that line. That means I want a line that has the same slope as this line. So I want to, off to the side, put that my slope that I'm going to use is 3. If it's parallel to that line, it has the same slope, so my slope is 3. Once I know what the slope is that I'm going to use for my answer, you can literally forget about most of the stuff from that question. Because all we need is we have the slope, now we have a y-intercept, we're putting in slope-intercept form, equal to x plus 5. Again, that minus 18 could be any number, and it doesn't matter. It won't change my answer. I can change that 18 to a 1,800, and it's still going to give me the same answer, because it doesn't matter what the y-intercept is of that line. All we're concerned about is the slope. So again, most people are usually okay with that because it's parallel, so it's the same slope. The time that it gets to be a little bit more confusing is number 7, because it's the same question. The only difference is I want something that is perpendicular to that line. Again, if it's perpendicular, I want the opposite reciprocal, so it's positive 2 over 3. That's the slope I'm going to use. Now, again, if you skip that where you don't write the slope, that is up to you. That is on you. But I always think it's helpful for students to do that, and then you can just kind of, again, don't cross this out on your paper, but we can forget about that equation now. We have our slope. They tell us what a y-intercept is, and so we have y is equal to 2 over 3x minus 10. A little bit, might be the next one, I'm not sure, is, so these I wanted in slope-intercept form. Eventually we'll have some that I want you to put it in slope-intercept form, but instead of giving you a line that's parallel and the y-intercept, I'll give you a line that's parallel and a point. So that's where we're going to start with point-slope form and then do the same thing we did yesterday. So I think that's what these next ones are. So number 8, write the equation of a line in point-slope form that is perpendicular, which is important. Perpendicular to is equal to over 8, x minus 2, 0.9, negative 6. So remember, minus y1 is equal to n times x minus x1. We're putting some point slope form, or like number 9 is slope intercept form. It doesn't matter which form we want. We're always going to start with point slope because they give us 1 point and we're going to find our slope. So not a bad idea, like I did with this one, is highlight where your slope is. And then again, I like to say, so the slope I'm going to use is the perpendicular, so it's opposite reciprocal, so it's positive h over 3. know my slope, I have my point. Minus y1 is equal to 8 over 3 times x minus x1. About the other day, my answer in form, I would like you to go ahead and take out the minus negatives. So we just have y plus 6 is over 3 times x minus 9. Now the next one wants you to put it in slope-intercept form. Again, the only difference would be you start that way, and then you have to solve it to get it into slope-intercept form. And again, I'm not saying that's easy, but that's what we did yesterday a bunch. So hopefully you guys are pretty decent at that, or hopefully this is more of a review for that part. So number 9, again, write the equation of slope-intercept to this line, and it goes through the point 4, 5. So again, form, but we have form because we have a point is the same. So I have y, my y1 is 5 is equal to 1 over 4 times x minus 4. But the way I did it yesterday, the way I'm going to continue to do it, denominator, my numerator to the right. So we have 4y minus 20 is equal to x minus 4. And then solve. So from here we add 20, add 20. 4y is equal to x plus 16. Then divide everything by 4. Over 4x plus 4. This one requires more work, but I kind of like this one for the sole purpose. I said this the other day. It's nice to check your work that the slope we started with, then having your answer. That's a good way to at least know you're on the right track. Doesn't necessarily mean you got the answer, but if you don't have the same slope, then it's definitely the wrong answer. Any questions on those? All right, I'm going to have you guys do 10 and 11 on your own. I'm going to try not to rush you, but I would like to stop with enough time for you guys to do those couple questions quickly. So my answers are up there. Again, make sure you're paying attention to the parallel versus perpendicular. I have students that miss this just because they go too quickly and they do all of them as parallel lines. Make sure you're paying attention. Number 10 wanted point and slope. Number 11 wanted slope-intercept. And ultimately, the biggest thing with number 11, again, your slope for this one is -1. So the opposite reciprocal is positive, and then 1 over 1 is just 1. So it's +1, which makes it kind of nice. You just have to distribute your 1 to the right. Again, if you're worried what to distribute to the left, you don't have to distribute anything. But if you need something, you could put it over 1. It just isn't going to change anything. Any questions on those before we move on? So I could very much be wrong, and I'm sure there's an argument for everything. But in my opinion, that's the hardest stuff for this lesson. That is mathy. This is the hardest stuff that you have to solve and plug numbers in and distribute and do different things like that. The next things I think are difficult, but it's not because they're hard with math. They're just very easy to confuse. So the first thing I want to make sure I tell you before we even start is that if you have x is equal to a number, that so we don't get confused, is very confusing. If you have y is equal to a number, that's a horizontal line. The other thing I want to make sure I say is that horizontal lines are perpendicular to vertical lines. I should have put that on here somewhere. So what that means is if you ever horizontal means a straight left and right line, up and down. Horizontal line is perpendicular to every vertical line. That's the whole idea. If you want proof or if you want a visual example, if you look at any of these walls that have bricks, every horizontal line, every vertical line is perpendicular. The other thing I'm not going to write down, but if you have two horizontal lines, they're automatically parallel. Again, if it's parallel line, same thing with vertical. If you have two vertical lines, they are obviously parallel. So, number 12 says a vertical line through the 3, 5. I don't mean to, but don't make this harder than it is. The hardest part is making sure you remember if it is a vertical line, that means I have to use that x is equal to. So I know it's x is equal to. Once you have that, I like this part because it makes sense. If I put x is equal to, you think I'm going to use my x value or my y value for this? The x value. So if x is equal to 3. And that makes sense if you think about it. This down, but just to tell you, if I pair is -3, 5, so it's up here somewhere. If I have a vertical line through that, if it's at -3, isn't that vertical line going to go through that x, so it's at -3? Yeah, that's the concept. However, if you don't remember that, that's fine as long as you just put that in your memory. So equal to -2. That's what that ordered pair means. So hopefully that part's not too bad, but it does get a little bit more complicated because the next one says, write the equation of a line that is parallel to x is equal to 4, and you go through the point 2, 5. Today so far, we're putting in a problem. It's parallel, but it's parallel to this line, just so happens to be vertical. Well, just like I said, if it's a vertical line, and you want a line that's parallel to it, you want another vertical line. Well, if I want a vertical line, x is equal to, what's it going to be x equal to? That x value at that point. So x is equal to 2. Now, the other thing that's really nice, you can also memorize it this way, where you know how parallel lines have the same slope? Well, you can almost remember that same. If it's parallel to x is equal to, your answer is going to be x is equal to. Your answer is going to be y is equal to. But again, make sure you understand the difference. The last part that we're doing here is going horizontal lines. So don't go rogue on the problems we did at the beginning and say that their x is equal to 2 or something like that. On these types of problems, don't say, oh, this one means x is equal to 9. No, not so much. That's not a vertical line. Number 15, what's the equation of a line that's perpendicular to y? Like I said, if you have a horizontal line, that means if it's perpendicular, it's a vertical line. So the line that is perpendicular to a horizontal line is a vertical line. So this is a horizontal line. So if it's perpendicular vertical line, x is equal to, then same pattern we've been doing, then if x is equal to 4. So go ahead and do the next couple on your own. 16, 17, 18. I'll put the answers up here. But go ahead when you're done with those, get out your computer. Please do those 3 problems. On those problems, again, I'm going to let you use your notes for now. A little bit later, but for now, I'm okay with that. But please make sure you're trying. If you don't try and you don't do very well, again, it's not a huge deal, except for that you will be for 30 minutes next week. You'll be in my class doing math, and I know that's not probably what you guys would like to do. I'm not offended, but please make sure you're putting forth the effort on those. All right, most of you guys come from here, but my answers are up there if you want to double check. Be careful with those. If you still need help, obviously let me know.